Hello, this is Hydratech, 24th of November 2013. What we have here are two systems. The first system is a waveform generator system composed of two parts. The first part being this Android device running a free waveform generator application, given control over such things as frequency, amplitude, duty cycle, so on and so forth, for a generated waveform that will be used as input to the second component of that system, namely this old Kenwood KA660 audio amplifier. That amplifier will amplify the incoming waveform and present the result to the used input of the coil via one of the speaker outputs at the rear of the device. Now, the waveform generator system has a power requirement which is such that it will need to be monitored continuously for comparative reasons as the tests progress. To that end, I'm going to use this device over here, in which the top row will display the instantaneous wattage, the middle row will display the RMS current, and finally the bottom row will display the RMS voltage, which taken collectively should hopefully give one a pretty good representation as to what the running power requirements are for the waveform generator system. That takes us to the second of the two systems I'd like to discuss, which is a power monitoring system of sorts. It is also made up of a number of components, the first of which is this one shown down here. This is nothing more than a homemade current probe, which will allow for a current carrying conductor to be passed through it from left to right, and in doing so, that same conductor will pass through a small ferrite toroid about which there are 50 turns of copper wire. And the idea there is that the current flowing through that conductor will induce a small voltage in the surrounding coil, and that coil will then allow for the delivery of that small voltage to this oscilloscope over here upon its channel 2 probe input, and then displayed on the screen as the lower of two waveforms. As the conductor exits the current probe on the right, it then goes into the 10 amp max input port on this right-hand most multimeter. So what are these used for? Well, the left-hand RMS, or so-called true RMS meter, will measure and display the RMS current at the used input of the coil. The right-hand meter will measure and display the RMS current at the used output of the coil, recalling that its 10 amp max input is coming from a conductor that has already been passed through this current probe. I'd just like to point out at this point that this current probe is in no way calibrated at all. However, should I wish to calibrate this device, all I need to do is compare its output to that of the output on this right-handmost meter and adjust it accordingly via the built-in 1K potentiometer, which is there for that purpose, hopefully to affect the sensitivity of the device. Now, that will take us to the first of the two oscilloscopes I will discuss. The one on the left will display two waveforms. The top waveform will be the voltage at the used output of the coil. The bottom waveform will be that of the current passing through the same used output of the coil, however, displayed as a voltage waveform. Just to give you an idea as to why I'm doing that, well, the whole point is to try and get some kind of idea what the phase angle relationship is between the two. However, the display method may not be necessarily as we see it right now. I could leave it like that and provide myself with a rough estimate. I could superimpose one upon the other using the Alt setting on the scope, or I could attempt something like a XY display like that. I haven't decided which method I will use, but the method I will end up using and will settle upon will be explained as and when I do so at the right time. Now, the channel 1 input, which corresponds to the top waveform, is using a by 100 attenuated high voltage probe. Channel 2 has no attenuation applied to it at all. It is simply a direct probe connection to the current probe. The time division setting for that is currently set at 200 microseconds, and that takes us to the second of the two oscilloscopes over here. Now this oscilloscope will also show, as we see, two waveforms. The top yellow waveform will be that of the voltage at the used input of the coil, while the remaining waveform at the bottom, shown in blue, will be the voltage at the used output of the coil. Each waveform will be accompanied with two values shown in corresponding colors along the bottom of the screen. The first two values will be the peak-to-peak voltage and RMS value for the top waveform, and the remaining two values will be the peak-to-peak voltage and RMS value for the lower waveform. Channel 1 and Channel 2, corresponding to the top and bottom waveforms, both utilize a by 100 attenuated high voltage probe. The whole point behind using these high voltage probes is to attempt to protect these devices. Incidentally, this scope on the left here is pretty ancient. It is in calibration. I have a calibration certificate for it. However, due to its age, it's pretty dicky really at this point in time, and I am considering replacing it with another one of these, possibly a 4-channel version, and this was only purchased a few months ago. Well, that's it for a description of the two systems. What remains now is to commence with the actual testing, the collation of the results, and the preparation of those results in both video and spreadsheet format for your perusal.